All right, here we go. So this is a review of or introduction of imaginary numbers. I'm going to give you information, run through some rules, do some example problems, and then I am going to show you how to accomplish it on your calculator if you have the TI 8384 Plus series. So here we go. What's the most important thing you need to know about imaginary numbers is that the way we write them is real value written first and then plus or minus the imaginary value. The imaginary value is the number that is multiplied by the I. Okay, this is called complex standard form. So I identified it here. A is the real number and we write it first in the binomial. And imaginary is the B value in this formula, written second, of course, okay? So this is called complex standard form in many books, all right? So this is the order. Now, I is kind of treated like a variable when we use it, but it has rules behind it, which makes it different, okay? So here is a lot of extra explanation, but here's what you need to know. I was invented so we can get the negative out from under a square root. Before, the square root of a negative would be undefined, okay? But now we're allowed to take the negative out and it becomes an I, all right? So now if we take I squared, so if we square that and if we use our rule of radicals, when you square a square root, it cancels. Those are inverses of each other, right? So my -1 comes out. So in other words, I squared is -1. Okay, then we go on to I cubed, so I to the third power. And if we want to just break down some of our rules, we can use I squared times I, and that would, of course, get us I to the third power. Now, of course, I am using exponent rules as well, so you should know your exponent rules. Can't review those right now, but here again is proof that I to the third comes out to be -I. And therefore, I to the fourth, if we use exponent rules, we would do I squared times I squared, and I squared is -1, right? So that would be -1 times -1, which is a +1. So what is the goal here? Well, I is when we want to take a negative out from square root. I squared, we will always have to change into its value, which is -1. I to the third, we would replace with a -I, and if we came across an I to the fourth, we would replace it with a 1. Now, we also have a repeated pattern of powers of 4. That is for another lesson, okay? So, moving on, let's do an example. So, using this rule of when I is introduced, we can get a negative out from under a root. This is what we need it for, because in the past, when we came across a square root of a negative, this would be considered undefined or no solution. But now, this is why imaginaries were invented, okay? So this is really, if I want to rewrite it, and I'm going to kind of give a little example here, the square root of 9, the negative square root of 9, can be rewritten using our multiplication rules as the square root of -1 times the square root of 9, right? True, let me zoom in, right? -1 times 9 is -9, right? Okay, so with that fact, then now the square root of -1 would be replaced with I. Okay, so the square root of -1 is now I, and we know that the square root of 9 is a perfect square, so that is 3. So therefore, now we have, when we simplify this, I times 3, or in other words, the square root of -9 would be 3I. And again, it would be written as if it was a variable. If this was 3x, we'd write it as 3x, or if it was x times 3, we would write it as 3x. So same with I. So this represents our imaginary 3, okay? And the I became an I because the negative was under the root, okay? Now, for the square root of -5, the problem here, again, we can write it down that the square root of -1 times the square root of 5, right? That would equal the square root of -5. Well, the square root of 5, that's prime, right? We can't go any lower. but we can take that negative out. So this negative actually comes out as an I. So we would rewrite this to simplify it as I, and the root 5 just stays root 5. But now it's written as a positive, okay? So that's our logic behind that. All right? I am going to come back with multiplication and division rules, as well as using your TI to do your imaginary and complex numbers, okay? That will be in my next video.